So this means definition of sarcasm in the comments of social networks. So detecting sarcasm is an exciting but challenging task for the text. There are no basic pointers such as intonations, facial expressions, or gestures. The use of sarcasm detection can benefit many areas of NLP. Sarcasm is a serve obstacle to improving the accuracy of mood analysis, especially on social media, as sarcasm depends mainly on the tone of your voice, the facial expressions and gestures that cannot be present in the text. Due to insufficient or missing context, vowed sarcasm in online messages can reserve the meaning of a statement that leads to confusion. Understanding the actual mood of online conversation can help businesses process customers' feedback and gather ideas to improve marketing in terms of processing, in terms of protecting and defense. Sentiment can be essential signal of online information transcations to identify problems or possible actions by attackers. And previous research used machine learning techniques to predict sarcasm in online conversation. In this study, I will also use data collection from text, hashtags from the Kaggle site based on Reddit comments and machine learning methods. So there are two types of methods, methods based on self-defined rules and methods based on machine learning. Methods based on rules for definition of sarcasm is due to peculiarities seen in sarcastic text. This study considers such a feature of sarcastic text as quotes. After all, a word that is not used in the original meaning is often quoted. This is done through gestures during verbal communication, but while text use punctuation. So syntax's properties play an important role in providing information about the syntax's structure of tweet. They include the pause part of speech function used in the work because it's better to work with parts of speech with an emotional meaning, such as nouns, adverbs, and adjectives. Of the linguistic features, I will use TF idea. So from what kind of machine learning methods I will use is logistic regression and naive Bayes classifier. As you can see, we will compare difficulty and accuracy of the models. The most difficult one is the rules base of the features extraction, and the better for accuracy is expected logistic regression results. This figure shows that the program creation should begin with a selection of data on which to build the model, and this can be done by data sites such as Google Dataset Search and Kaggle. Then you need to pre-process the data. This step turns the text into a more digestible form so that machine learning algorithms can work more effectively. Next is converting text data into suitable for working with machine learning methods. It's translating words into vectors. You can also pre-process the text, extracting other features needed to determine sarcasm. After successful vectorization, the data will divide into two data sets, one for training future models and other for texting. And then the building of the model begins. After the successful construction of the model, the results are presented in a matrix, confusion matrix, and accuracy of the models. and will be shown on the graph. In this study, the data were vectorized by tokenization and based on features such as TF, IDF, and POS. And the results are shown by the values of accuracy, F-score, and confusion matrix. So here is the result. Features like tokenized, POST, TF-IDF, and TF-IDF combined with POST, accuracy and F-scored, and two models of logistic regression and bias classifier. So the combination of TF-IDF and POST gives us better result on both models using only TF-IDF properties. Logistic regression has better accuracy than bias classifier on both types of properties, and the best accuracy is in logistic regression, which trained on TF, IDF, and POS, is 69.11% accuracy. And the worst is in the bias classifier trained on POS, is 49.94% of accuracy. The combination of TF, IDF, and POS of approximately of 1% improves the accuracy of the model compared to sample of TF, IDF. And the models train only on token data and only on features of parts of speech gave the worst results. So this is the four models with the worst results, the POS based on POS features and tokenized features. And here is four models with the best results. It's TF-IDF features and TF-IDF with POS features. Models trained on frequent features and a combination of frequent features and part of speech shows accuracy that are better for about 15% in comparison with simple features. When we were comparing the matrix, we could see the large proportion of incorrectly classified data. Most models identify many sarcastic text as non-sarcastic. This is confusion matrix for worse results, for worse models, and this is confusion matrix for models with better accuracy. Like naive bias is trained on tokenization and feature parts of speech, and logistic regression are trained on chance sign language. Logistic regression introduced on token data indicates more non-sarcastic text than are sarcastic. And metrics where higher accuracy looks much better. Also, logistic regression and naive bias trained on frequency features, and POS with TF, IDF are more significant number of non-sarcastic texts than are sarcastic. Here is it that tends. In future work, you can consider more pragmatic properties on the text, such as number of word marks and exclamation points. We can also extract new syntaxes based on words like oh, wow, and language symbols that represent smiles like lol, ruffle, and act, and smiles and emojis and hashtags can also be defined as the properties. And also it would be good to build new models based on machine learning and in-depth learning in the future. And that's all.